Another type of problem that's really easy to solve using triangles are load factor problems. So here we're asked to figure out what the load factor is on an airplane that's in a 60-degree bank. So first, let's remind ourselves what happens when an airplane is in straight and level flight. When an airplane's in straight and level flight, it's neither climbing nor descending, which means that it's exerting exactly 1 g of force downward toward the ground. It has to, because 1 g is the amount of force that gravity is imposing on the plane pulling it down, so the wings have to be providing exactly that much lift up, otherwise the plane will start to climb or descend. Well, when a plane's in a 60-degree bank, it's doing the same thing. If it's not climbing or descending, it's still exerting 1 g of force directly toward the ground. It has to be. That's basic math. But lift doesn't operate, or lift always acts perpendicular to the wings. So in this case, the wings have been rotated 60 degrees. In order to generate 1 g of force toward the ground, they have to be generating a lot more force in the direction perpendicular to the wing. So this is starting to look kind of like a triangle, right? Well, hopefully it works out. We have a 60-degree angle between the direction that the wind is actually the direction that the lift is actually operating and the component of the lift that's pointed to the ground. And the only thing that we know is that the component of lift toward the ground is 1 g. So we overlay our right triangle on here, and what do? Well, we have an angle. We have the length of the side adjacent to the angle, that's 1 g, and we're asked to solve for the hypotenuse, which is, in this case, labeled as x. So that's a perfect setup for a cosine problem, because the cosine uses those three things. So let's plug in our values. Cosine of 60 equals 1 g over x. Solve for it, and we get x equals 2 g's. Pretty straightforward. We go back to our question, look and see that 2 g's is one of our choices, and in fact it's even better than that, it is the correct choice. So in general, you can always solve a load factor problem without looking at the chart by just doing 1 divided by cosine of the bank angle. It's that easy. Just punch that into your calculator and it's done. But it's probably even easier to just visualize the triangle, because then you don't have to try to memorize the formula and run the risk of getting it wrong. So the traditional way to do this problem would be to use a chart, or maybe I should say a graph, like the one that's on the screen now. So how does this graph work? How does this graph allow you to get to the correct answer? Well, to solve the problem, the procedure you would use is you would trace across the bottom of the graph to your bank angle, move up, find the line, and then trace across to the left to find your load factor. And you get an answer, which is correct, of course, of 2. So how does this graph actually get you the correct answer? Well, it turns out that if you plot, using a graphing calculator, 1 over the cosine of the bank angle, you get exactly this graph. So all this graph is doing, or all this particular chart is doing, is allowing you to read the value of the cosine, or really 1 over the cosine, read the value of that function off of a chart. And it's just as quick, or quicker, to type it into a calculator, and a lot more precise.